Welcome back to The Explainer, everyone. Look, if you're building software right now, you already know the ground is shifting incredibly fast beneath our feet. I mean, the sheer volume of AI updates, new models, and framework releases, it can honestly be completely overwhelming. So today, we're cutting through that noise. We're going to dive into some really fascinating insights to build out a 2026 AI infrastructure blueprint. We'll explore what the sources say is actually shifting in the industry so we can make smart architectural decisions today that won't force us into total rewrites tomorrow. Let's get right into it. Right off the bat, it turns out the pace of innovation, it is not slowing down anytime soon. IBM technical experts have made that absolutely clear for 2026. We are literally seeing architectural changes, entirely new hardware capabilities, and huge application layer expansions happening all at the exact same time. A recent analysis by Vignesh Selvaraj really nailed this down, identifying 7 specific technology areas that are driving this massive wave. And guys, this isn't just a story about faster models. We are exploring entirely new ways to build software. So here's our roadmap for today's explainer. 1. The 2026 AI landscape. 2. The new AI baseline. 3. Active engineering challenges. 4. Exploring distant frontiers. And finally, 5. Your developer action plan. All right, jumping into section 1, the new AI baseline. Think back for a second to the 2022 to 2024 wave of AI. If your app needed to, say, process a voice memo, look at an image, and then summarize it, you were basically duct taping together 3 separate APIs, right? You had transcription, vision, and language. Honestly, it was a routing nightmare. But the 2026 baseline, it features natively multimodal foundation models. Think GPT-4o, that's the archetype here. Now, a single endpoint handles text, images, and audio all at once, totally bypassing that clunky behind-the-scenes pipeline. This is exactly why text-only is already considered legacy tech. By moving to just one endpoint, your architectural surface area shrinks dramatically, and all those annoying failure modes just consolidate. So the core trade-off we really have to evaluate now as developers is simply this: operational simplicity versus your cost per token. Building on that new baseline, we've got to talk about what's actually under the hood now. So from 2020 to 2024, the transformer architecture totally dominated, right? But if you look at the latest research, next-generation neural architectures are seriously stepping up. We're seeing things like state-space models, like the Mamba family, and mixture of experts designs. Now, mixture of experts, well, it essentially saves computing power by only activating the specific parts of a model's brain that are actually needed for a given task. It's super efficient. To be clear, these aren't here to wholesale replace transformers, but they do solve those massive memory and latency bottlenecks when you're dealing with huge, long documents. The practical signal for us here is that model selection is no longer just about looking at the parameter count. Actually, a smaller, highly efficient state space model might totally outperform a massive transformer on streaming tasks. Moving right along, Section 2, Active Engineering Challenges. Okay, the absolute biggest paradigm shift happening right now is the move from model as completion to model as agent. It used to be that a model produced a single output, and boom, it stopped. Well, not anymore. Agents actually take actions. They plan out a sequence, they call external tools, observe the results, and iterate until the goal is finally met. Frameworks for this, like LangGraph, Claude's Tool Use API, and OpenAI's Assistance API, they moved into early production back in 2025, and they are rapidly consolidating right now in 2026. But the truly fascinating, and let's be real, kind of messy engineering challenge today is memory management. We're all trying to figure out how to handle tool failures and infinite loops without the AI just losing its context or crashing in a live production environment. Now, alongside agents, we're also exploring a brand new category that's forcing some very explicit architectural choices: reasoning models. The best way to think about this is like fast reflexes versus deep thinking. Standard models? Those are your quick reflexes. They're great for fast, real-time user interactions. Reasoning models, on the other hand, like OpenAI's O-series, are much more like deliberate, focused thinking. They run this extended internal computation before they ever produce an output. It's basically trading inference time compute for massive parameter counts. And the trade-off is super explicit here. You are sacrificing speed, and you're paying a higher cost per query, but in return, you get vastly superior correctness in multi-step logic, complex math, and coding tasks. For us developers, this means we should be deploying reasoning models for batch tasks where correctness is absolutely essential, and saving those standard models for real-time chat where a user expects an instant reply. The final active challenge, which is honestly also an incredible opportunity, is edge and on-device inference. The whole industry is rapidly pivoting toward highly capable models running completely locally, with zero API calls to the cloud. I mean, think about the benefits. You get offline capability, significantly lower latency, absolutely no per-query API costs, and privacy guarantees that cloud inference literally cannot offer. No way around it. And this is all becoming a reality thanks to dedicated neural processing units, or NPUs. These are essentially specialized hardware chips built specifically for AI math. Combine that with massive advances in model quantization, which basically squeezes models down to a fraction of their original size, and the capability gap between local and cloud models is closing super fast. If mobile or embedded systems are anywhere on your roadmap, tracking local inference is an absolute must. Which brings us to Section 3, Exploring Distant Frontiers. First up in these distant frontiers is AI for science. Look, beyond things like AlphaFold, the 2026 landscape shows AI radically accelerating the entire hypothesis and test cycle. We're talking materials discovery, drug synthesis planning, climate modeling, genomics, the whole shebang. But what's really intriguing for us general software developers is that the systems being built for this incredibly complex, structured scientific data, well, they're actually starting to bleed over into general-purpose developer APIs. Understanding how this structured discovery works could seriously give you a fascinating edge as these tools become more mainstream. And that naturally leads us into physical AI. These are models that directly control robots and physical systems, actually integrating language models for task planning. We're watching this leap right out of the research phase straight into early deployment. Think humanoid robots and advanced robotic systems from players like NVIDIA and Boston Dynamics. But here is the interesting part. The immediate entry point for software developers isn't actually hardware. It's simulation. Tools like Isaac Sim let you test robot controllers synthetically. And the emerging API patterns in those environments, getting early familiarity with them is a genuine and maybe somewhat unexpected career advantage right now. All right, let's wrap this up with Section 4, Your Developer Action Plan. So, synthesizing everything we've looked at today, here is your playbook for 2026. For multimodal APIs, which are available right now, your main takeaway is to consolidate your endpoints to save on architectural complexity. Just simplify it. With agentic patterns moving into early production, your focus really needs to be on mastering memory management and those planning loops. For reasoning models, when you're doing batch tasks, remember the golden rule. Prioritize correctness way over speed. You've got to test them against specific real-world tasks rather than just relying on generic benchmarks. And finally, for edge inference, the advice is simple. Track it very closely if mobile or embedded systems are anywhere on your immediate horizon. Which leaves us with one pretty critical question to think about. Are your current architectural decisions going to survive the next 18 months of AI shifts? The sources strongly suggest that these are profound shifts at the infrastructure layer, not just the application layer. But by understanding this blueprint and tracking these specific technological leaps, we can hopefully make smart decisions today that won't require us to totally rewrite our applications tomorrow. Thank you so much for exploring this with me on today's Explainer, and I will see you in the next one.